4.2, writing and solving equations. So we had a little bit of practice with this in chapter 3 when we started to write simple equations in standard form. Today we're going to continue with writing equations, but we're also now going to solve the equations as you did in yesterday's homework. Looking at example 1, the relationship between Celsius and Fahrenheit is represented by the equation C equals 5/9 times F minus 32. So it should be obvious that C represents our temperature in Celsius in this equation and F represents our temperature in Fahrenheit in the equation. A. Determine the Celsius temperature that is equivalent to 58 degrees Fahrenheit. So F gets replaced with 58 and I solve for C. So C equals 5/9 times 58 minus 32. I have to follow BEDMAS, so I first do what's inside the brackets. 58 minus 32 is 26 times 5/9. So first, this is 26 over 1, so I could multiply first the 5 times 26, which gives me 130, divided by 9. So that's my exact answer, 130 over 9. Or I could go ahead and divide that out with my calculator and get an approximation of 14.4 degrees Celsius. Part B, determine the Fahrenheit temperature that is equivalent to 25 degrees Celsius. So this time, the C gets replaced with 25 and I need to solve for F. So the way I'm going to solve for F is by isolating F, which is what you did in yesterday's homework. Notice the equation becomes a little bit more complicated. So I need to, in order to isolate F, I need to get rid of the 32, I need to get rid of the 5 and the 9. Okay, I need to move those all over to the other side. Now, remember when we're isolating, it's always inverse operations, which means I follow BEDMAS backwards. So the first thing I'm going to get rid of is the 9. I'm dividing by 9. When I move it over to the other side, I multiply by 9. So I have 25 times 9 equals 5 bracket F minus 32. Now to get rid of the 5, I'm multiplying. The opposite would be to divide. So 25 times 9 over 5 equals F minus 32. In one step, I could have jumped from here to here. 25 equals 5/9. Instead of taking that 5/9, breaking it up into 2 steps, I could move the entire fraction 5/9. I'm dividing, which means I flip my fraction and multiply. So 25 times 9/5, there it is. Okay, it's the exact same thing. I could take steps. I could do it in intermediate steps, or I could jump straight to 25 times 9/5, whatever you are most comfortable with. So we're at 45 now equals F minus 32. I'm going to take the negative 32, move it over to the left-hand side. It becomes positive, and we end up with 77 degrees Fahrenheit is our equivalent answer. So in that example there, we isolated, but the original equation was given to us. What's going to happen, or what we're building up to, is being able to write our own equations. So in example 2, that's what we are going to do. I am a number such that when you add 13 to me and then divide by 4, you get 21. What number am I? So I'm going to start by assigning variables. That means I'm going to pick whatever letter I want to choose, and I'm going to tell everyone what that letter represents. So I'm going to choose X, and I'm going to say X is going to be this certain number that we're solving for. So X is my number. Now, let's read. I'm a number such that when you add 13 to me, so that means X plus 13, and then divide by 4, so X plus 13 divided by 4, you get 21. So these two words here, you get, translates to equals in mathematics. So there it is, X plus 13 divided by 4 equals 21. So I need to solve this. I did not need to put brackets around X plus 13. That's up to you. You do or it doesn't make a difference. Okay, those brackets aren't going to change anything. It's important that you recognize I'm dividing all of X plus 13 by 4. So when I go ahead and solve, my first step, I need to follow BEDMAS backwards, is to get rid of the division. So I move the 4 over and I multiply 21 times 4. So we're left with X plus 13 equals 84. I'm going to take that 13, move it over to the right-hand side by subtraction. X equals 84 minus 13. X equals 71. And since this was a word problem, we should be ending with a word sentence, a statement. Okay, so therefore the number is 71, and that would give full marks on a test. Let's look at one more example. Example 3, a rocket is launched from a hill that is 700 meters high. The rocket's altitude increases by 30 meters every second. Write the equation you would use to determine when the rocket reaches a height of 1,000 meters, and then solve. So I'm going to start by assigning my variable. I'm going to use x. Let x be the number of seconds. We need to remember that our rocket is increasing in height by 30 meters every second, so x represents the number of seconds. So we're starting at 700 meters, we're increasing by 30 meters every second, and we want to arrive at a height of 1,000 meters. So there's my equation, 700 plus 30x equals 1,000. I now need to solve this problem. So I'm going to take the positive 700, move it over to the right-hand side. When I do that, I end up with subtraction. So 30x equals 1,000 minus 700. 30x equals 300. To get rid of the 30, because I want to isolate x, I'm dividing both sides by 30. So 300 divided by 30, x equals 10. And again, I'm going to conclude with a statement. This was a word problem, so we must end with a word statement. Therefore, it will take 10 seconds to reach 1,000 meters. So for homework today, I'd like you to look at pages 202 and 210 again, okay? If there are any problems, please reach out to me and I will get back to you as soon as possible. Thanks, guys. Have a good day.